Here's some chemistry questions and how to solve it by Nadya Shabira from 10E. So, starting from questions I got from paper 1. Which molecule has an equal number of bonding electrons and lone pairs? So, to find the answer to this question is we need to make the Lewis structure of each molecule from the options. And if we make the Lewis structure of each molecules, we will find that carbon dioxide has 8 bonding electrons and 8 lone pair electrons. So it has the same amount of lone pair electrons and bonding electrons, so therefore the answer is B, which is carbon dioxide. Jumping to the next question, methane and steam react to produce hydrogen. So here's the reaction. 0.8 grams of methane and 1.35 grams of steam react. One of the reactants is used up. Which volume of hydrogen measured at room conditions will be produced? So to find the answer to this question is we have to find the amount of substance of methane first by finding 0.8 by 16 equals to 0.5, and to find the amount of substance of water we divide 1.35 by 18, and then we got 0.075, and 0.075 is for 2 moles of water, so we divided that by 2 equals to 0.0375, and between 0.0375 and 0.5, 0.075 is smaller, so therefore we use this for the amount of 1 mole of everything in the reaction. And so the amount of substance of hydrogen is 4 times 0.0375, which is 0.15. And to find the volume, we have to times the amount of substance times 24 equals to 3.6 liters, which is B. Jumping to the next question, a 200 milliliter sample of water has an amount of oxygen gas dissolved in it. The amount of oxygen gas has a volume of 6 milliliters when measured at 1 times 10 to the power of 5 pascals and 25 degrees Celsius. What is the concentration of oxygen gas in the water? You should assume that oxygen behaves as an ideal gas. So, to find the answer to this question, we use the ideal gas equation, which is PV equals to nRT. So the pressure is 1 because 10 to the power of 5 pascals is 1 atm times 0.006, which is 6 milliliter converted to liters, and then the n is what we're about to find, and this is the ideal gas constant times 308, which is 35 degrees Celsius converted to Kelvin. And then the mole is 0.006 divided by 25.256 equals to 2.37 times 10 to the power of minus 4. And to find the molarity, which is the concentration, it's the amount of substance divided by the volume. So it's 2.37 times 10 to the power of minus 4 divided by 0.2, which is this 200 milliliter to liters, and it equals to 1.185 times 10 to the power of minus 3. Since this is the closest to option B, which is 1.17 times 10 to the power of minus 3, so therefore that is the answer. Jumping to the next question. A student mixed 25 milliliters of 4 mol DM to the power minus 3 hydrochloric acid with an equal volume of 4 mol decimeter to the power minus 3 sodium hydroxide. The initial temperature of both solutions was 50 degrees Celsius. The maximum temperature recorded was 30 degrees Celsius. The heat capacity of the final solution can be assumed to be 4.18 joule per Kelvin gram, and the density of the solution can be assumed to be 1. Using these results, what is the enthalpy change of neutralization of hydrochloric acid? So to solve this question, we use the formula Q equals to mc delta T. So the mass is 50 because 25 plus 25 milliliters equals to 50 grams times 4.18, which is the heat capacity, times 15, which is the delta T. so it equals to 3,135 joules. And to find the delta H, we use the formula minus Q divided by N. So we need to find the N. So the mole, or the amount of substance of hydrochloric acid, is the molarity times volume. The molarity is 4 times 25 divided by 1000, because we converted to liters. So the answer is 0.1 mole. So 0.1 mole is the amount of substance of hydrochloric acid. And so we inserted to this formula, and it equals to minus 31,350 joules, which is minus 31.35 kilojoules, which is option B. So why minus? Because this is boiled, which is combustion, so that's why the delta H is negative. Okay, jumping to the next question. Carbon monoxide and methanol can react together to form ethanoic acid. So this is the reaction. So what is the value for delta HR for the reaction between carbon monoxide and methanol? So to solve this question is, so here is the general formula for delta H of reaction. So we insert the sigma, the energy enthalpy combustion of reactant, which is minus 283 plus minus 726 minus subtracted by the sigma energy enthalpy change of combustion of the products, which is minus 874.1. So if we calculate that, we get minus 134.9 kilojoule per moles, which is B. So therefore the answer is B. Next question. A student calculated the standard enthalpy change of formation of ethane, C2H6, using a method based on standard enthalpy changes of combustion. He used the current values for the standard enthalpy change of combustion of ethane, which is minus 1,560 kilojoule per moles, and hydrogen, which is minus 286 kilojoule per moles. But he used an incorrect value for the standard enthalpy change of combustion of carbon. He then performed his calculation correctly. His final answer was minus 158 kilojoule per moles. What did he use for the standard enthalpy change of combustion of carbon? So to find the answers to this question, we use this formula here. So now we insert the delta HR is minus 158 kilojoule per moles. So it equals to the sigma enthalpy change of combustion of the reactant, which is 2x plus 3 times minus 286 minus the sigma delta enthalpy change of combustion of the products, which is minus 1,560. So equals to minus 158 equals to 2x plus 702. So the amount of x, and then we divide it and calculate it, and so therefore the final answer is minus 430 kilojoule per moles, which is C. Next question. So ethane C2H2 completely combusts as shown in the equation. So this is the equation. Using the average bond enthalpy in the table, what is the enthalpy change of combustion of ethane? So to solve this question, we use the formula to find the delta H and bond energy, which is bonds broken minus bonds formed, the energy required for bonds broken minus bonds formed, or the energy needed, the energy in the reactant minus the product. So the reactant is 2 times 410 plus 840 plus 2.5 times 496 equals to 2,900, and the delta H in the product is 2 times 460 plus 4 times 740, which is 3,880, and so we subtract 2900 with 3880 equals to minus 980 kJ per mole, which is A. Next question. So carbon monoxide and methanol can react together to form ethanoic acid. So this is the reaction. The standard enthalpy changes of combustion are given in the table. So this is the data. And to solve this question, we're going to use this formula, which is the enthalpy change of reaction is the delta HC of the reaction minus the delta HC of the products. So it's minus 283 plus minus 792 minus 674.11, which is the delta HC of the product. And so the final answer is minus 134.9 kJ per mole, which is B. Ta-da! Next question. So the enthalpy change for neutralization of HNO3 with NaOH is minus 57 kJ per mole. In an experiment, 20 milliliters of 4 mol DM to the power minus 3 HNO3 is mixed with 20 milliliters of 2 mol DM minus 3 NaOH in an insulated container. The initial temperature of both solutions is 25 degrees Celsius. It can be assumed that the heat capacity of the product mixture is 4.2 joules and that there are no heat losses. So what is the maximum final temperature of the mixture? And so to solve this question, first is we make the reaction first, which is this, and then we find the amount of substances of HNO3 and NaOH with the formula molarity times volume. And so these are the results. And because 0.06 is the smallest amount, so that is what we're going to use. And so delta H equals to Q minus Q divided by N. So Q is delta H times N. So the delta H is 57,000 here, note in here, times 0.06 from here equals to 3,420. And so we know that Q equals to MC delta T. So to find the delta T, we can insert these data in the equation and then do some calculations, and we got that the delta T is 60.3. And so the final temperature is the initial temperature plus delta T. Why plus? Because this is clearly neutralization and combustion here, because Q empty delta T, and so yeah, that's why the answer is 41.3 Celsius, which is option A. Next question. So 4 mixtures are added to 4 separate 50 milliliter samples of water and stirred. Which mixture results in a solution with the highest pH? So as we know, aluminium oxide and aluminium chloride is neutral and an acid, and so neutral plus acid will result in an acid product. And for option B, magnesium oxide and magnesium chloride is base plus neutral, and so the pH of the product will be based. And in option C, we know that phosphorus oxide and phosphorus chloride is both an acid, so it will result in an acid product. And we know that in option D, silicon dioxide and silicon chloride has pH neutral and acid, which results in the pH of the product being acidic. And so the mixture results in a solution with the highest pH is option B, which is magnesium oxide and magnesium chloride. So yeah, the answer is B. I mean, of course, the result will differ if the amount is different, but here in this question the amounts are same, and so we can use this method. So next question, which mixture will react to form exactly 1 mole of water? So how to solve this question is first we need to make the reaction which results in 1 mole of water here. And so in the reaction, the N of H the N of H2SO4 to produce 1 mole of water is 0.5, and the amount of substance of sodium hydroxide to produce 1 mole of water is 1. So we need to find these qualities in the options. In option A, the H2SO4 is 0.5 and the sodium hydroxide is 0.5, which doesn't match the quality. In option B, the amount of substance for H2SO4 and sodium hydroxide is 0.5 and 1. And in option C is 1 and 0.5, and in option D is 1 and 1. So the qualities of the options that match with these is option B. So therefore the answer is option B. Next question. So aqueous acid P and aqueous alkali Q have the same concentration. 20 milliliters of P is added to a conical flask. Q is slowly added to the flask and the pH are recorded. The titration curve is shown. The pH titration curve is shown here. And so which row gives the identity of P and Q? So here are the options. So to solve this question, we see that at volume Q at the volume of Q added, the pH is like see when the volume of Q added is 0, the pH is already more than 0, and this is the qualities of a strong acid. So we eliminate this CH3COOH, and at the end of the curve here we see that at the volume of Q added is when the volume of Q added is 20 milliliters, so the ratio of Q and P will be 3 to 2, and the pH is 14. So this is the quality of a strong base, and so NH3 is out. So our option is A and C. And so here we can see the volume of Q added at 10 milliliters is when the neutralization occurs when the volume of Q added is at 10 milliliter. Well, here we see that the P is 20 milliliters. So we know that HCl have a 1H plus. So we need something that can hydrolyze it doubly, which is BaOH2 because it has 2 OH minus, and at ratio volume of P to Q is 2 to 1 is already neutralized, so it has 2 OH minus. So the answer is C, which is HCl for P and BaOH2 for Q. Next question. Sulfur dioxide is used as a preservative in winemaking. The following equations describe how sulfur dioxide dissolves. So here are the equations. So which statement about these two reactions is correct? So as you can see, the pair of reactant of HSO3 is always H plus. See, like HSO3 minus plus H plus, HSO3 minus plus H plus, and H plus is clearly acidic, so HSO3 is of course base. So that is why the answer is A. Next question. In which reaction is the underlying substance acting as a base? So here are the underlying substance. So in option A, H3SO4 is an acid. H2SO4, typo guys. is an acid, and in option B, HCN is also an acid. In option C, HCO3 is a base, and in option D, CH2 ClCO2H is an acid. So the answer is C. Ta-da! Next, okay. So now we're jumping to questions that I take from paper 2. So, first question from paper 2 is complete the diagram to show the number and relative energies of the electrons in an isolated atom of silicon 14. So here is the electron configuration of silicon with 14 electrons, and so we just convert it to this table, which results in this. Next question. Most elements exist naturally as a mixture of isotopes, each with their own relative isotopic mass. The mass spectrum of an element reveals the abundances of these isotopes, which can be used to calculate the relative atomic mass of the element. Magnesium has 3 stable isotopes. The information about 2 of these isotopes is given. Calculate the percentage abundance and hence the relative isotopic mass of the third isotopic of magnesium. Give your answer to 3 significant figure. So we can use the formula here, which is AR times 100 equals to the percentage, the sigma percentage abundance plus relative isotopic mass. So we insert the quantities from the data and ended up with 24.8. So 24.8 is the isotopic mass, and here the percentage abundance is 10%. So how do we get 10%? It's by 79 plus 11 is 90, right? And then it results in 100. So 100 minus 90 is 10%. So that's how we get the percentage abundance. Next questions. Give some details of the stable naturally occurring isotopes of rhodium and iridium. So to get these qualities, number of protons is shown here. So 45, 77, 77. Number of neutrons is the amount of nucleons minus number of electrons, which is the number of nucleons minus the number of protons. So it's 58, 114, and 116. And so the total number of electron shells for rhodium is 5. How? Because first you make the electron configuration, and the biggest electron shell or energy level is 5. So therefore the answer is 5. Next question. So here we're shown a table of 3 isotopes and its quality, and we are told to calculate the relative atomic mass AR of iridium in the alloy. Give your answers to 2 decimal places. So to solve this question, here we know that the relative abundance in alloy is 50. It's 50.18 plus 34.82. And so the AR of iridium times 50 equals to the sigma of the relative abundance in alloy times the relative isotopic mass, and then we got these numbers, and then we calculated it, which is 9670.64 divided by 50, which is the amount of the surplus of the relative abundance in alloy, which is 192.35. So 192.35 is the relative atomic mass of iridium. Next question. So we're told to define the relative atomic mass. So the relative atomic mass is the weighted average mass of an atom of an element compared to 1/12 of the mass of a carbon-12 atom. Next question. So this table shows the abundances of 2 of the isotopes present in the sample of iron. Use table 2.1 to calculate the relative isotopic mass of the third isotope of iron in the sample showing working. So to find this, we use the formula that we have been using, and then we insert the numbers we got from the table above.
Udah ada ustaznya.
And so it's 5,580 equals 322.4 plus 5,127.21 plus 2.1x. And so to get x, we divided 119.39 divided by 2, which is 56.85. Next question. So table 1.1 gives data relevant to the reaction of Cl2 with NH3. So we are told to calculate the enthalpy change of the reaction in this reaction. So first we make the equation, and so we calculate the delta HR with the formula of the sigma delta HF product minus sigma delta HF of the reactant, and then we insert the data to the formula, which is 6 times minus 82 minus 2 times minus 46, which results in minus 460 kilojoule per moles. And so yeah, that's all for me. So yeah, I hope you guys find my video informative and you're able to learn something new from my video today. So yeah, that's all from me. Thank you everyone. Bye. See you guys